Good afternoon, everybody, and welcome to our extra classes. I am Marinda Lombard, and I am the Head of Department for Geography at Goutveld High School, that is in Welkom. Before we start this afternoon, I would like to show you that my first language is actually Afrikaans, but I will do my best to explain everything to you in English. And please feel free to ask me a question if you do not understand anything that I have explained. When we start with the topic of drainage basins, the very first thing that I want to show you is things that you will find in the paper. I have been a marker and a senior marker for a few years now. And I've seen some rather strange things when we go marking. So please look at the following and check that you see everything before you start answering your paper. The very first thing is, always read the instructions to the question paper. This is very important. Every subject has a different kind of paper, a different kind of instruction that you have to follow. In geography, you are getting a paper with 4 questions, of which you only have to do 3. Please remember, only do 3 questions. That you will also see at the beginning at the instructions to the paper. Then you must follow the instructions to the letter. If the instructions say that you must number in the middle of the page, please number in the middle of the page. You will also see that the instructions at geography reads that you must leave the sides, the spaces on the sides of the paper open for the marker to mark and allocate the marks. Please remember to do that. Otherwise, the paper turns into a mess of blue, black, red, green as the paper continues through the marking system. Then, write with a pen of good quality. I've seen some rather messy writing because of a pen that blots. Please make sure that you buy a quality pen. It doesn't have to be a very expensive one, but one that will do the work for you so that you can read and write legibly. Make sure of the questions you want to do. Take time to read through the paper before you start. Make sure of the questions that you want to do. See how many questions of each section you can answer. And see that you answer the questions that will give you the most marks in the end. Then, and this is very important, please write legibly. As I told you, I've been a marker for a few years now, and this is true. Markers work for very long hours. We start at 7 in the morning and we knock off at 7 in the evening. Then we have a few breaks in between. Those breaks add up to about 2 hours. So please, write in such a way that you will be able to read your own writing. If I can give you an example of what I've seen in the past, if we can have a look here, we got that. Is that now an S or is that now a V? After several discussions, we found that that was supposed to be an S. When you number, we get the following. To me, that looks like a 3. Believe it or not, about 40% of the papers that I have marked the past few years, that was a 5. So please make sure that you write in such a way that people can read your handwriting. Then, number correctly. Remember, if you number incorrectly, the answer will not be taken in the logical order of the memo. For instance, if you number 4.3.2 and the numbering was supposed to be 4.3.3, we will not follow the memo. We will follow the numbering. And although your answer may be correct, it will not be marked correct because you have numbered incorrectly. This is very important. Use the annexure to the paper to answer your questions. I had a learner 1 year who told me that he never even opens the annexure because he doesn't know, it's just a lot of pictures. Remember, the answers that you must write must be according to the picture, to the sketches that they give you. Otherwise, what are you going to answer? Whenever they give you a question and say, refer to picture 3.1.2 or whatever, look at the picture and base your answer on that specific picture. For other pictures in your mind does not comply to that answer. So please use the pictures given to you. And then, if you cannot put yourself in words the way that you want to, and you read through your answer and you think that your answer doesn't really make sense, please make a drawing of that you want to say, whatever you want to say. That can lead the marker to the kind of answer he thinks that you want to give, and you can maybe score 1 or 2 marks there. Right, before we continue, I would like to say, when we go to the topic of drainage basins, you guys must remember, drainage basins are huge features. Drainage basins is not something that you can fit into a room, a classroom, school grounds, and sometimes not even into your own province. So make sure that you keep that in mind. A drainage basin is a huge thing. It covers a huge amount of kilometers, sometimes even thousands, like the Mississippi and the Orange River. So make sure that you keep that in mind as we go through the slides. Right, let's start. The very first thing that you must remember when we do drainage basins are the following. There are certain features that we will cover as we go along, and please make sure that you do understand all the meanings of the following. You must know what a drainage basin is, a river system, a tributary, an interfluve, and a watershed. Okay, let's start. The very first feature. What is a drainage basin? As you can see on the screen, a drainage basin is the total area drained by a river and all its tributaries. Now, when you look at the picture, you will see that we have dotted lines all around that river. If we look at what a drainage basin is, you will see that all the areas, ground and water, between those dotted lines are a drainage basin. With other words, the whole area that contributes to water in that river, in that specific system between those dotted lines, is called a drainage basin. There you can see an example of phase 2 of the Lesotho Highlands Water Project. That is the whole drainage basin for the Lesotho Highlands Water Project. Have a look. Can you see? Hundreds of kilometers are covered by this water project and by this drainage basin. The next one. These are a few drainage basins in South Africa. As you know, South Africa is not the biggest country in the world, but it is rather huge when you have to calculate the kilometers. So if I say that a drainage basin is a huge area, can you see that the whole of South Africa is covered by rivers and tributaries? Here we have a picture of all the drainage basins in South Africa. Clearly, you can see the Orange River there in the south. You can see the Limpopo River on the border between South Africa and Zimbabwe. And you can also see the Vaal River. And here I just want to point something out. You guys must remember that the rainfall or the precipitation that we do in the climatology can be connected to the drainage systems or the water systems in South Africa, because the amount of rainfall decreases from east to west. Now in this picture, you will see to the eastern side or to the right-hand side of the escarpment, we get a lot of rivers. But to the left-hand side or to the western side, we get rivers, but not as many as we do on the eastern side. Now for those of you who do have last year's question paper with you, you will remember that they have asked a question of how will a river on the western and on the eastern side of the escarpment differ? Remember, if you look at that picture, rivers on the eastern side has more water. Therefore, more erosion will occur. Therefore, those rivers will be steeper compared to those on the western side, which will have less water. They will be more gentle in gradient, and they will be more episodic or periodic rivers and not permanent rivers like the ones on the eastern side. Now we come to the next feature. What is a river system? Now learners get confused a lot between a river system and a drainage basin. Remember, we said a drainage basin is the total area that contributes to a river. Now, a river system. When we talk about a river system, we will see that it is the main stream and all the tributaries to the main stream. With other words, on this sketch, it is everything in blue. Look at the definition again. The main stream and all the tributaries, with other words, everything that contribute to the main stream. If you have to make sure between the definitions of a drainage basin and a river system, remember, a drainage basin is the total area between the watershed going all around that drainage basin. A river system is only the water parts of that system. Right, now we come to interfluves. Please make sure that you do not make a mistake of saying that an interfluve is a watershed. Remember now, an interfluve is a higher lying area between the different individual tributaries. It is not the area that differs one drainage basin from another drainage basin. So in that little picture, you will see that an interfluve is between the small rivers that flows towards the main river. It is not the outside of the whole drainage basin. Then we come to a watershed. A watershed is an area or a reach of land that separates the different drainage basins from one another. In that picture, you will see that the watershed is the higher lying area. When it rains, as that cloud indicates, waters will start running down to the left and down to the right. When water starts flowing in another direction to another river, the place where that happens is a higher lying area that we call a watershed. Do not confuse it with an interfluve, the previous one. Remember, the interfluves are between the different tributaries. With other words, the different contributors to one river. A watershed is something that is higher lying between two different drainage basins. That is a common mistake that learners always make. Now, when we recap, we will see a drainage basin is the total area covered, the tributaries, the higher lying areas, and the main river system. The river system, those are only the water parts. A tributary is a contributor that carries water to the main stream. An interfluve is the higher lying area between the different tributaries, and the watershed that is around the whole system, the whole drainage basin. And that is the area that lets the water go down on one side or to the other. If you guys have any questions that you want to pose, now is the time to do that on any one of those 5 items. Meanwhile, we are going to continue. If we look at a drainage basin, now remember, I'm going to say this again. A drainage basin is a huge area, several kilometers long. There are 2 ways in which water can go into that drainage basin. The very first one is surface runoff. You will see the picture on the right. That is when water starts flowing over the ground. And then the second one, and this is the one that we don't always understand because we cannot see it. It is added to the river from the bottom. That is groundwater. If I can explain it to you quickly, if you look at that picture, the surface runoff will be the parts that will start flowing on the green grass over the top. And the groundwater, those are the water particles that will go into the ground. It will infiltrate. With other words, that will be the blue parts. Now, what will cause water to either infiltrate or run off? Please remember, the runoff and the infiltration form part of the river system and the drainage basin. Okay, if you've been in the Free State for the past week or so, you will know that over the weekend we had soft, ongoing rain. If the rain is soft and it is over a longer period, water will infiltrate. With other words, it will go into the ground and it will form groundwater. If it is like a thunderstorm, a flash flood may occur, meaning that that hard rain will not be on the ground as long as it is for and then go into the ground. It will start running off because it is hard and it is continuous for a short period. So the hard rain over a short period will cause runoff, and the softer rain over a longer period will cause the water to infiltrate. The next factor is the soil moisture content. If the soil is already filled with moisture, it will no longer be able to take up any moisture, and then naturally the water will start running off at the top because the ground is full, to put it in straightforward words. But soil that is dry, with other words, after the winter season in the central parts in the Free State, we get dry ground because we do not have winter rain. Then, as soon as it starts raining, like it did over the weekend, and it is soft and ongoing, the water will start going downwards into the ground, creating groundwater. It will take up the moisture, and that will cause infiltration. Right, let me explain it to you in this way. Start from right to left. You will see that the ground on the right-hand side is dry. Okay, forget everything else on that sketch. Just look at the right-hand circle at the top. Do you guys see that there's a little water in it? Not a lot. As we move from right to left, you will see that gradually the water becomes more, until on the left-hand side, the water is saturated. And that will cause the water to push out of the ground and cause runoff. Then the next factor is vegetation. Now, this we know for the past few question papers always contained something about vegetation and runoff. The more the ground is covered with vegetation, the more infiltration, with other words, the more groundwater will form. Why? Plants slow down the flow of water. Their roots capture the water. The plant itself slows it down. The water has time to infiltrate into the ground, with other words, causing groundwater. And therefore, the more the ground is covered with vegetation, the more infiltration we will have. But if the ground is not covered with vegetation, we will have more runoff, as there is not enough plants to keep the water back, and therefore the water will just start running off. There you will see an example. The green patches are the ones covered with vegetation, and then the brown ones are not covered. So in that specific picture, the areas with the brown will cause runoff, whereas the areas with the green will cause more infiltration. Right, now we come to slopes. Now slopes is something that is actually common knowledge. A steep slope will cause water to run off, and a gentle slope will cause infiltration. Now you know that if I take water and I pour it slowly over a level surface, the water will start meandering or making little circles or jamming up. But if I tip the table over, I am increasing the gradient. Therefore, the water will run off very fast. Now we come to two features that causes a lot of problems for candidates. The one is porosity and the other one is permeability. Let's look at porosity first. The definition of porosity in straightforward, understandable language is the number of air spaces in a rock. Okay, if a rock has a lot of air spaces, or if ground cover or a kind of ground cover has a lot of air spaces, then it will be very porous, and therefore the porosity of the rock will be great. This will cause water to flow through and will therefore cause infiltration, and non-porous rocks will cause runoff. Right, let me explain this to you. If you look at that sketch, the black parts are examples of air spaces. Now, it is the same amount of ground. The left-hand side, you will see, has less air spaces than the right-hand side. Okay, so therefore, the right-hand side has more air spaces in it, and if the water wants to go in, and we have to measure the two of them, the water on the left-hand side will be more than the water on the right-hand side. That is the porosity. Remember now, those are equal in number. With other words, it's an equal amount of ground. It's an equal amount of soil. The left-hand side has more air spaces. The right-hand side has less air spaces. Therefore, the water will be more on the left-hand side. The other one is permeability. Now, permeability is sometimes confused with porosity. Remember, porosity are air spaces. Now, permeability is the willingness of the ground to let the water through. In primary school, you were taught that sand will let water go through more easily than clay. Okay, so if you have a lot of clay in the ground, it is less permeable. And the area covered by sandstone will therefore cause more infiltration than the area covered with clay. Now, this is an example of a real study that they have done. They took an equal amount of soil. The one was gravel, then sand, silt, and clay. They poured an equal amount of water on all 4 of those ground components. It was 1 meter in total. After 2 minutes, and then they, as you can see at the bottom, they put a tap at the bottom of that container containing 1 meter of soil. At the end of the study, it took 2 minutes for the water to go through the gravel up down to the bottom, and it was able to tap it out. After 2 hours, it had infiltrated through the sand, and they could let it go through the tap. Then after 200 days only, did it go through 1 meter of silt, and it reached the tap. And then nobody lived as long, but they estimated that it would take 200 years for it to reach the tap in the clay ground because it never ever came through. Now that is permeability. If we can just recap, I want you guys to make sure the difference between porosity and permeability. Remember, porosity is the number of air spaces in the rock. If it has a lot of air spaces, it will be very porous, and therefore the porosity of the rock will be great. In other words, the water will have to go through. But the solid parts, if there are more solid parts and less air spaces, then the rock will not, or the water will not go as easily through the rock. The permeability is the willingness of the water to go through. And there we have the distinction between sand and clay or silt or gravel. That is the willingness. In other words, do I want you to go through or do I want you to stay on top? Right. If there are any questions, please post them now before we continue. Now we come to something that is always difficult to the candidates, because I think it contains math, and everything that contains math is always seen as a challenge. But please be sure, this is not as difficult as it seems. When we come to stream orders, it is very important that you guys must remember, stream orders must start from the outside and we have to move inside. All right. That is an example of a drainage basin. It doesn't say which drainage basin, but please remember that a drainage basin is a huge area over a lot of kilometers. All right. Let's recap quickly. Do you see the main stream? Do you see the tributaries? Do you see the interfluves? The watershed and the river system? Please make sure that you guys can identify all 5 those features. Now, we are going to start numbering them. The reason why we want to determine a stream order is because we want to see the highest order stream. For instance, if they give you 2 examples of drainage basins and they ask you to determine the stream order at a certain point, they can also ask you which one of those 2, when you compare them, has the highest stream order, whether it be A or B, or say for instance the Tugela and the Orange River or whatever. Okay, rule number 1. start numbering from the outside inwards. With other words, when it rains in the watershed, on the watershed, which of them, of those tributaries, will get water first? Those are numbered 1. The moment that two number 1 streams flow together, like you have at the bottom, right above number A, where it says plan view of a basin, look right above that. There we have two one-order streams. Those one-order streams flow together and they create an order 2. Now, very important, look a little to the top. We get another one-order stream flowing together with a 2-order stream. Can everybody see that does not create an order 3? Only when we go up more to the top, we have an order 2 and an order 2 flowing together, which will cause an order 3. Which eventually, when those two order 3s flow together, we get an order 4. So, remember, start from the outside, numbering inwards. Start from the first tributary, numbering inwards towards the main stream, up to the point where you are asked to number. And that can be anywhere on that sketch. Usually, they do it at the basin outlet. With other words, there where the water basin flows into the sea. Excuse me. That is usually where they ask you. Questions that can derive from this is, what is the order of the stream or the drainage basin? So they can say, what is the order of the stream at, say, for instance, A on a sketch? Then you have to calculate from the outside inwards up to point A. That point can be at anywhere in that drainage basin. Anywhere. They can say, what is the number order of the drainage basin? Then you have to go all the way up to the end to where it goes into the sea. They can also ask you questions about drought and heavy rainfall or floods on a stream order chart like this. Okay, questions deriving from drought. This is also one that was in the last exam. What will happen to the order 1 streams in a dry season? Can everybody see? They will dry up, or they will become less because it is not raining as much. So what is going to happen now? Order 2 is going to be 1, 3 is going to be 2, so in the end we will only have an order 3 stream. What will happen if we have a lot of rain? A period that has over the average of rain. Then the order 1 streams will become more. I don't know if you guys can remember, a few years ago we had a lot of rain. It was about 3 years ago. It started raining on the 16th of December and it continued over a long period, soft rain that continued over a long period. By New Year, we had floods. So, places that never ever had a small river now suddenly had. That is the reason why we say that more order 1 streams will occur if it is a heavy rain season. If it is a drought season, then the order 1 streams will become less or it will be dry. Here is another example. This one is in color. Do you see the order 1 streams are all in blue? Order 2 is in green. Important to see, only when 2 orders of the same flow together, it creates a next order. So 2 order 2s flowing together creates an order 3. This is very important when you write the practical as well. Remember, at any certain point, they can ask you what the highest order of the stream is. Start numbering from the outside inwards. A huge mistake that the candidates make is by starting to number from the main river outwards. Remember, order 1 is the very first stream that will receive rain if it falls. There is just a classification. Please look at A and B. You will see in the end they both come down to order 4. If you guys have any questions, please post them now so that we can make sure that you guys understand. The next topic is something that you will certainly and most definitely get in your practical, and that is drainage patterns. Excuse me. Now that you know what a drainage basin and a river system and all those other things are, we can start looking at drainage patterns. Drainage patterns is something that we only learn in grade 12, but we start doing them from grade 10 in the practicals, when your teacher will give you a question paper and one or two of the questions will be identify the drainage pattern in, say for instance, block B4. Right. Now when we look at a drainage basin, we will be able to identify certain patterns of drainage. Those you have to know by heart. Nobody will give you them on a piece of paper and you have to choose them A, B or C. Okay? Those you must be able to identify and know by heart. Look at the pattern that the water forms when it flows. Now remember, the pattern that we can see is the surface runoff. But water is also being provided from the groundwater pushing upwards. Okay, identify the drainage pattern and then you must be able to answer all the questions according to the different patterns. Now, depending on what kind of textbook you guys are using, because we have a lot of different textbooks, you will see that in each textbook, and I had a look, they tell you what the drainage pattern is, they give you an example, and then they tell you on what kind of cover it flows. You will see in just a minute. Okay, here is the one that everybody knows by heart. This is the dendritic pattern. On the left-hand side, you will see the features of the dendritic pattern. The very first thing is, it looks like a tree. But now, this everybody knows. But now, please remember, do not write the tree-like pattern in the exam. It will not be marked correctly. It looks like a tree, but it is not a tree-like pattern, it's the dendritic pattern. It is the most common drainage pattern that we can see on the topographical maps, and it is found in areas with the same ground cover. Right, this I want to explain. Areas with the same ground cover is areas that is everywhere as hard or everywhere as soft as it is to the adjacent area. Okay, we've commonly found it in massive igneous rock, and it can also be found in sedimentary layers. Look at the example. Can everybody see that that is like a tree? It looks like a tree. Now remember, when you have to start numbering it, if you have to determine the stream order, you have to start on the outside, numbering down towards the main stream. Now it gets a little more difficult because the streams are not differing in thickness. That's why I say, do a few of these. It may only count 2 or 4 marks, but maybe those are the 2 or 4 marks that will let you pass, fail, or get a distinction. The next pattern, or the second most common one, that is the rectangular pattern. The features of the rectangular pattern is we get it at igneous rock. That igneous rock has cracks and seams. The streams form rectangles where they meet. Now on the right hand side, that is the kind of feature that you will see on the topographical map. This is how it looks in 3D. You see it is streams will follow the cracks. Do you see? There are cracks in the ground and the streams will follow those cracks and may join at a 90-degree angle. I just want us to go back to the dendritic pattern quickly. Everybody see it's a tree-like pattern and it is found in areas with the same ground cover with, for instance, massive igneous rocks. Then the rectangular pattern. Do you guys see? It looks like rectangles. It can meet at a degree of 90. There it is in 3D. Now we come to the trellis pattern. The trellis pattern and the rectangular pattern are sometimes not very identifiable or distinguished between the candidates. The features of the trellis pattern are, it is found at inclined rock. There is a differing hard and soft rock. We can also get it at parallel crease mountains. Okay, now, those short streams that you see at the trellis pattern, those are formed on softer rock. Those softer rock are eroded faster by the water. Remember, you will also be able to have to do questions on stream orders on any kind of drainage pattern. So remember, start numbering from the outside inwards. In this case, I want you guys to have a real good look at the difference between the trellis and the rectangular pattern. The trellis pattern, that is a more finer pattern. The streams are a bit shorter compared to the rectangular pattern, which are longer. Please do not confuse the two of them. Questions that has derived from these, you have to identify them on the topographical map, and then that is a practical question. Then they can also ask you in that practical, on what kind of rock will this kind of pattern evolve? So remember, in the morning you are writing the theory. Do not forget these things over lunchtime. Now we come to the radial pattern. The radial pattern and the next one, the centripetal pattern, is very, very easy. Because the radial pattern is the one that flows outward from a higher point. Okay, and it looks like the spokes of a bicycle. There I put a bicycle rim for you, and you will see the spokes. Compare it to the right-hand side. You see it flows outward from a higher point. When it starts raining, it will flow downwards from that volcano. There is one on the topographical map. The next one is the centripetal pattern. That is just the opposite of the radial pattern. The features of this pattern is that it flows to a lower point from higher points on the outside. Look at the sketch. That was taken from a real topographical map. If you look on the outside and you look very carefully, you will see that those contours are very close to each other. So that shows us that that is a higher lying area. Then the water will flow inwards, downwards, but inwards from those higher points to, say for instance, a pan or something like that, or a dam or a lake. Whereas the radial pattern flows outward from one central higher lying area. The very last pattern, and this I gave to my grade 10s this year, is the deranged pattern. Now, at the deranged pattern, I want to almost say, if all else fails and it doesn't make sense, it is deranged. You first go down from your dendritic pattern down through your whole list of patterns before you write that something is deranged. Okay, there are different points of flow. There is no identifiable pattern, but if you look on the right-hand side, you will see that there are different streams flowing towards different places of gathering. So those black spots there are dams or lakes that gathers the water as the water flows down. Compared to a dendritic pattern, it doesn't fit. Trellis doesn't fit. Rectangular doesn't fit. Radial and centripetal doesn't fit the features. So does everybody then agree that now we have the deranged pattern? And as I say, I've been a teacher for 15 years now, and I've only found one deranged pattern that I gave to my grade 10s this year, but please do not cut it out. It can be a possibility. Okay, let us recap quickly. The dendritic pattern is the tree-like one. The rectangular pattern, that is the one that has the rectangles. The parallel one we do not have in our textbooks. Now the trellis pattern, look, the difference between those two. Trellis are more finer. Deranged pattern, and then the radial and the centripetal pattern is easy. If you guys have any questions, please post them now. I'm really willing to help you with those. Following are stream channels. Okay, when we get to stream channels, you will see that we have two flow patterns. The one is the turbulent, and the other one is the laminar flow. The turbulent flow. There is a picture of turbulent flow. Features of it is a restless flow. It has a lot of erosion. If you look at that, you will see as the water moves along, it takes along everything that is on the sides, that is at the bottom of the river. So that's why we say it is a restless flow. A lot of erosion, and the turbulent river has an uneven riverbed. Now remember, the riverbed is the bottom part of the river. That is the part where the water meets the ground. The riverbed is where the groundwater is infiltrated or is filled into the river. The uneven riverbed causes friction. Friction means the particles move together. It is not something that flows easily. It is almost keeping the water back, and therefore the water's movement is slower. The water takes on a brownish color, sometimes with foam, and it looks like water boiling in a pot. It's moving the whole time. It's going, and you can compare it to water boiling in a pot. The particles is flowing. Whereas to laminar flow is a more peaceful flow. Guys, this does not mean that the water flowing laminarly is not fast. Please remember that. And that is a huge mistake that people make when they go swimming in a river. Laminar flow is a peaceful flow. Doesn't mean that the water is going slowly. You can still drown or be taken by streams in water flowing laminarly. Be careful of that, because it is at the top, it looks peaceful, but at the bottom the water can still move very fast, although your eye can't see it. These are the feature of the laminar flow. It is a peaceful flow. There are less erosion, and the laminar riverbed has an even surface. This even riverbed causes a slower movement of water. Right. If we look at the water particles in a turbulent and in a laminar river, this is what it will look like. Look at the top one, the turbulent river. Do you guys see that the water is moving around a lot? The particles are moving around, bouncing, whereas the laminar flow, it is more peaceful and more even. Pictures that I got from this is, look at this one. At the bottom, you will see laminar flow. As soon as that water goes over the rock at the bottom of that riverbed, it starts flowing turbulently. Now, if you guys has ever gone white river rafting, or if you've seen it on TV, please make sure that a riverbed that is uneven, that is called a rapid. A rapid. So the water flows laminarly, and then you will always see these people going wild and crazy. What's going to happen now? We're going to hit a rapid. Right, that's when the rapid is when the water starts going turbulently. This is also a good example. The water on the left-hand side is flowing laminarly, and the water on the right-hand side is flowing in a turbulent manner. Please make sure, look at that picture. It doesn't necessarily mean that the water is going to be brown when it starts flowing turbulently. Please remember that. Look at the movement of the water. You guys can see that is a more boiling pot kind of water flow than on the left-hand side. I want us to recap everything that we did real quickly before we take a break. Remember what a drainage basin is. It's the total area drained by a river and its tributaries. Remember the river system. That is the main river and all the tributaries to it. Remember the difference between an interfluve and a watershed. And then remember how water gets to the surface and why it infiltrates rather. The factors that will cause the water either to infiltrate or run off. Remember that is precipitation, the kind of rainfall that you get. The soil moisture content, is it already filled with water or not? If it is, it will start running off. If it is not, the water will infiltrate. The amount of vegetation, if there's a lot of vegetation cover, then the water will be kept back and it will rather infiltrate. When there's less vegetation cover, then the water will start running off. The slopes, gradient or steep. The porosity or the air spaces, and the permeability or the willingness of the water to go through. Remember the stream orders, start numbering from the outside inwards, and then the drainage patterns, very important, dendritic, rectangular, trellis, radial, centripetal, and deranged. And then please make sure that you know the characteristics of turbulent flow and laminar flow. We will be back in a few minutes. Please take a break and do feel free to ask any questions if you'd like. Welcome back, everybody. I hope that you enjoyed your break. Back to the drawing board. Now we come to types of stream flow. I just want to stress again that all the things that we are doing today can be asked in the practical paper as well. So please make sure that you go through these things before you write the practical 2 o'clock in the afternoon. Do not forget them over lunch. The next thing that we are going to do are the types of stream flow. Now here we have 4 different types. A according to the features of each of these, you will have to be able to identify them. Now, I have had a look at the past few question papers. They didn't really ask these questions in the practical paper as such that you had to identify different features, but please make sure that you know the different rivers in South Africa that has these characteristics. For instance, when we come to the permanent stream, we can relate that to rivers like the Orange River, the Mississippi River in South America, and those are rivers that the height of the water almost never change. With other words, we do not get a river or a period where the river is dry and then it has a lot of water, and then dry and a lot of water again. The level of the water almost always stay the same, and it has water all year around. So during the seasons where there is not a lot of rain, so for instance in the Free State, we do not get rain normally during winter time, the water will not dry up, or the river will not dry up. Then the periodic rivers, these are rivers that can occasionally run dry. Examples of these will be like the Sand River, the False River, parts of the Vaal River, which is above the water schemes. They are usually located in arid climates where the evaporation, with other words, the amount of water that is taken up by the sun is more than the precipitation, with other words, of the amount of rain that falls. Okay, so please make sure of those two, the difference between the permanent stream and the periodic stream. Now we get to the episodic river. The episodic river is a difficult one because it rarely occurs and it is formed from the runoff channels in very dry regions. These are rivers that can cause floods. And examples, a good example of an episodic river is the Buffels River. If you study the part in your textbooks, if it has the floods of Laingsburg in it, you will know that the Buffels River is a river that never, ever had water for 100 years, almost 100 years. And then people started building in the riverbed. They started building houses, old age houses. They built bridges there. They built bridges for cars and bridges for trains. Because it is an episodic river, it only flows when it receives a lot of rainfall in the catchment areas. The catchment area is in the higher lying area, and the water starts flowing through level 1, level 2, level 3 streams all the way up to the main river or the main stream. What's happened then is that once in almost 100 years, the Buffels River started flowing again, and overnight people drowned because they built their houses in the river bed. The next one is the exotic river. Now, a good example of the exotic river is the Nile River and parts of the Orange River in South Africa. If you have a look at Uppington, which is only a few hundred kilometers from here, you will know that that is a very hot and a dry town. They say that in a few years' time, because of global warming, people will not be able to live in Uppington anymore because it will become too hot. Now, if you look at the Orange River, it is a huge river that permanently flows through this dry Northern Cape region. That is an example of an exotic river. Another good example is the Nile River. The river of the Nile flows through the sandy, through the desert parts of Egypt. But it is a huge river. Sometimes at some parts it is so huge that you can't even see the other side of the river. Those are examples of exotic rivers. Any questions on the kind of rivers or the kind of streams, please feel free to ask. Let me recap quickly. A permanent stream is where the height of the water almost never change and it has water all year round. These two are the most commonly confused. And then the periodic river is the one that can run dry on occasion, depending on the water or the amount of water or the rain season, things like that. The episodic river is one that rarely flows, and it only flows when there is a lot of runoff. With other words, when there is a lot of flow from the sides or a lot of rain. And then the exotic river, those are the ones that are the odd ones out. It flows through a very dry, arid region, but it contains a lot of water. And that is the purpose. That is good to have a river like that, because you can still live in a deserty place, but you can still have enough water. That's why the people in Uppington use the water of the Orange River for irrigation. Now we come to stream channels. This is very important in the practical. As you can see, I took that picture from a real topographical map. The first kind of stream channel is the braided stream. In Afrikaans we call it die vlegstroom. The characteristic of a braided stream, it is found in areas that is flat or in areas with a low gradient. Braided streams occur when the amount of the water in the river is reduced. So, say for instance, it is the rainy season, which in the Free State is summertime, and it goes into wintertime. Then the amount of water that river is carrying can decrease. That is called a periodic river. Do you remember? It is the one that changes with seasons. Now, as soon as the amount of water in the stream reduces, the amount of baggage, now I say baggage, meaning the amount of debris that the river has to carry, that increases, or it looks like it becomes more. And then the flow of the river will slow down. So this river flows over loose and soft material, and all the eroded material from the sides of the river then forms islands in the middle of it. If you have a look at that picture, you will see the river is flowing around these islands. Then usually, if you have seen braided streams before, you will know that there are usually a lot of bird life activity on these islands. Birds make nests there, and then in the evening when you go camping or whatever, you can hear them singing. The next one is the meandering stream. That was also taken from a topographical map. In Afrikaans we call it a kronkelstroom. At the meandering stream, you guys must remember that the gradient is very low and the erosion is greater or more on the outside of the riverbed. That outside can fall in and it can cause a river hang. But first I want you to be able to identify the meandering stream. There is a picture of it, so that one is in real life. The previous one is on the topographical map. When we go back to braided streams, that is how it looks in real life. And that picture is how it looks on the topographical map. So remember for the practical. Now this one, the rock-controlled stream. This one is not very much easy to identify on the topographical map. Pardon me. There you can see that the sea. That is just an example. This is in a rainforest. This picture was taken in a rainforest. As you can see, there were harder and softer rock that were eroded away. The softer rock was eroded away, and now you will see it flows over the hard rock. That is the one that was left, and the water follows the patterns of the cracks in these rocks. As I said, This one is not easily identifiable on a topographical map. If you look at a waterfall is also a kind of rock-controlled stream because the waterfall starts forming from the hard and the soft rock that differs. The soft rock is eaten away first, and then the hard rock remains. So the water flows over the hard rock and falls into that pit that the soft rock has formed. Any questions on the different streams, please feel free to ask. I just want to recap them quickly. It's the braided one. The braided one is the one that forms the islands in the middle. Then the meandering one, kronkelstroom in Afrikaans. That is the one that has a lot of bends in it. And the rock-controlled one is the one that is not easily identifiable on the topographical map. Okay, now we come to the dreaded flood hydrograph. For some reason, the pupils and the learners do not like answering questions about hydrograph, and in fact, it is easy marks, easy to obtain. You must just be able to read the flood hydrograph. So let me show you how easy it actually is to do. When we look at a flood hydrograph, remember a flood hydrograph is a graph that they draw to indicate how fast a river will go into flood over a period of time. With other words, did it take 4 days for the river to go into flood after it started raining? What is the highest level that that river reached when it went into flood? Now, there are 4 very important features to identify on a flood hydrograph. And if you know these 4, and if you know how to read them and interpret them, you will see that flood hydrographs are actually very easy. The very first thing that we have to remember is the rising limb of the flood hydrograph. Now the rising limb, you will see on the picture, is the left-hand side. That is for the river to go into flood. How fast did the water rise? The falling limb is just the opposite of that. How fast did the water level go down when it went into flood? Then the peak is the top, and then we come to the lag time. The lag time you will see on that hydrograph, it is where it says the time to peak. Now, let's look at this one. The rising limb is the one on the left-hand side. That is how fast the river went into flood. The falling limb is the one on the other side, how fast it took for the river to go out of flood or for the water to go down. And then the peak flow is how high it went. Lag time is how fast or over what period did it take the river to go into flood. There is a real storm hydrograph that I took from the internet. I just want to explain something to you quickly. As you guys know, there is a difference between the rural and the urban flood hydrograph. Let's look at the urban areas. It is covered in non-permeable, non-porous surfaces like cement and tar. In the rural areas, the ground is covered by either soil or vegetation. Now, please make sure that you guys know those 4 features because we are going to apply them to these 2 areas. Let's recap quickly. You must know what the rising limb is. You must know what the falling limb is, the peak, and the lag time. Right, here we go. If you look at the top of that picture, you will see that the lag time is the time that it took since it started raining until the river went into full flood. With other words, until the river reached its top level of flooding. That is the lag time. Now, when we look at that graph, we will see. Look at the rising limb of the urban stream flow. That is the light blue one. The pre-urban stream flow is the purple one. Now, let me just go through it quickly. Remember, pre-urban is when it was rural, before there were tar and cement surfaces. The urbanized stream flow is afterwards, when we covered everything with houses and bricks and tar and cement and things like that. Right, let's compare those two limbs. The rising limb of the urbanized stream flow. Can everybody see that that one is steeper? The gradient is steeper than the pre-urban or the rural areas. Reasons for that. Remember, urban areas are covered in non-permeable, non-porous surfaces. With other words, we just learned that that will cause water to run off and not to infiltrate. Can everybody see? The river or the water in the urban area will go into flood very quickly, or more quickly than in the pre-urban or in the rural area. Now let's look at the falling limb. The falling limb, we said, indicates how fast the water runs off or goes away, or the water that has caused the flood runs off or it disappears. Look at the urbanized area. Can you guys see? It's very steep, whereas the rural areas one is more gradual. Reasons for that. When it starts raining and it causes flash floods in the urban area, it will go into flooding very quickly. The water will run off into the gutters and the gullies, and it will disappear. In the rural areas, we have vegetation that can take in the water, and therefore it will take longer. The water will infiltrate more than it does in the urban area, and therefore the falling limb of the urban area's hydrograph is steeper than the pre-urban one. Now let's look at the peak. The peak is the highest point that the water will reach in that flood. When you enter Laingsburg, those of you who have been there, you will see there is a pole about, if I can say, 100 meters from where the river now flows, or the river doesn't flow because it is episodic. And that says Vloedhoogte 1988. The height of the flood in 1988. Guys, that is the peak. That is the highest area, or how high will this river rise until it starts going down in the flood season, or in that specific particular flood. And now we come to lag time. For some reason, the learners do not understand the lag time. In Afrikaans, we call it die vertragingstyd. The lag time is since it started raining and the storm reached its highest until the river went into flood. That will be the lag time. Now, in urbanized areas, can you guys see that is the light blue one? It will be very fast. Water will start running down very fast. The flood will occur very fast. You've seen in the past weekend, we had some broadcasts of the Western Cape that had huge flash floods. Whereas in the rural areas, the purple one, do you guys see that the peak is much lower? Reasons? What we did right at the beginning. The permeability, the porosity, the vegetation, those all causes infiltration and not runoff. Therefore, remember, a flood is a lot of runoff. It goes fast. The water flows fast. It takes along everything that there is. Remember, guys, the features. The rising limb, the falling limb, the peak, and the lag time. Here is another example of the effects of development on runoff. The red one is the urban area, the yellow one is the suburban area, and then the rural area is the green one. Look at it. Red one, urban areas, goes into rising limb fast and steep. The rural areas, more gradual. The falling limb of the urban area, fast and steep. The rural area, more gradual. Look at the peak of the urban area. It's very high. The rural area, much lower. And then you will see the lag time. With other words, the time it took for the river to go into full flood, to reach its maximum, is much slower in the rural area than it is in the urban area. There's just another example. If there is any questions, please feel free to answer this. This is not a question that they will originally ask in the practical, but please make sure that you are sure of all these different features of the storm hydrograph or of the hydrograph. The rising limb, the falling limb, the peak, and the lag time. And they will also be able to ask you the difference between the urban and the rural area in runoff and infiltration. Now, if I just have to think quickly, and if I had to set a topographical map question, I would ask questions like, in the urban and rural areas, you must identify the rural area. Say, for instance, it will be C4 and the urban area is C2. Which one, C2 or C4, will cause more runoff, more infiltration? Which hydrograph will have a steeper falling limb and a steeper rising limb or a higher peak, something like that? Please make sure of these features of the flood hydrograph. Now we come to river profiles. Guys, there are two profiles to a river. The first one is the longitudinal profile, and the other one is the cross profile or the transverse profile. Let's start with the longitudinal profile. If you guys want to write down this quickly, the longitudinal profile of a river is the profile from its origin, that will be in the higher lying area or in the mountains, downwards to the permanent base, and that is to the sea. So I'm going to say again, the longitudinal profile is the profile of the river from its origin all the way down to where it flows into the sea. Now, the longitudinal profile of a river is the one that is always trying to, working hard to become concave. As you will see on your screens, that profile of the river is concavenal. You can see it starts from the highest point in the mountains, and it goes down gradually towards the sea. Guys, if a river has that concave profile perfectly, or almost perfectly, we say that that river is graded. That is a graded river. Every river in the world strives and works to being graded. But as soon as that river reaches a graded stage, that whole process of erosion, deposition, that whole rock feature thing, that lead mountain, the volcanoes, that lead mountains go up again, that moho thing that we did in grade 10, that sets in again. So it is important to understand that for a river to be graded took hundreds, maybe thousands of years. And for it to be graded can take, in river ages, only a small time, because the earth will start doing things again to make it not being graded. Right. There we can see the longitudinal stream profile of a river. If you see a profile like that, you know that it is graded. Remember, it's from the start in the mountainous or in the higher lying areas all the way downwards to where it mouths into the sea. Now we come to the transverse or the cross profile. Now guys, here we take the river, we cut it across, we climb into it, and we have a look at it. There is a top, a middle, and a bottom part. Let's look at the top part. Please remember and keep in mind that transverse or that cross profile of that river that you see is hundreds and hundreds and hundreds and hundreds of kilometers long. It is not a short thing. It is not only 10 kilometers. Those are hundreds of kilometers. Okay, that's the top part. Look at the shape. It is V-like, closed. A closed V. Look at the sides there at A. It is steep. Look at the amount of water in it. It is less than the other two. Reasons for it. That top profile of the transverse one is at number A. That is at the top part of the river. And we say that where it originates a river, it is mountainous. It is hilly. Okay, so is the gradient steep or is it more gradual? The gradient is steep. Therefore, will it cause a lot of erosion or less erosion? A lot of erosion. So do you see it eats downwards? It is a steep gradient. How much water is in that river? Only the water that it takes when it rains. Right. So therefore, that is why A is steep, narrow, with not a lot of water. Now, look at the tributaries at B. Do you see more water starts flowing from the higher lying areas? Therefore, the amount of water at B will be more or greater. But now, look at the shape. Can you see that as the water starts flowing in from the sides, it starts eroding those steep sides away, and now it is more open V shape. And then when we get to the bottom, we have a lot of water, because now all the tributaries that could contribute to this river has already put its water into this mainstream. Now, the more water, the more erosion. Therefore, the V is almost flat. It is an open system that is almost flat. Now, when we look at this, you must remember that the meanders will be found in the less gradual, in other words, in the area with less gradient, therefore at the bottom. Okay, now that's also an example. I want us to look at the long and the cross profiles. They have taken this one. This is a very good sketch if you want just to try to remember all these features. Look at the longitudinal profile. Can everybody remember what that one is? From its origin to the mouth. Is that profile graded? Yes, it is. Why? It has a concave form. There is nothing in there like waterfalls or things that has a temporary base level. Look at the top. They took that longitudinal profile and they cut it up, and then they showed us how every single part of that one looks. look at the vertical or the downward erosion that is more noticeable at the top part, then it goes more gradual in the middle, and it is almost flat in the lower reaches. The amount of water increases as it goes downwards. Please remember, erosion is greater at the upper level, less in the middle level, and at its lowest at the lower level. The amount of deposition is less in the upper level, bit more in the middle reach, and then in the lower reach it is the most, creating that gentle gradient. If they ask you about the V shape, remember, in the upper valley it is steep, with other words it has a close V shape, and then as you go down the V will become greater. I want to make sure that you guys understand that. If there are any questions about this, please feel free to ask it now. Now we come to base levels. Remember, base levels are only categorized into two categories. The first one is temporary and the other one is permanent. Now, temporary base levels are everything that store water for a short period and then let it go in, is called a temporary base level. Examples are dams, lakes, waterfalls. Look at that profile. Can you see that it is not graded? It is not the perfect concave profile. So that is not a graded river yet. It will be in a few hundred years' time, depending on the layers, the soft and the hard rock. They will be able to, you will be able to, they will be able to ask you questions on the base levels. You must be able to identify them on the topographical map, as well as on a picture that they give you. Remember, a temporary base level is something that stores water for a short period of time or for a period of time and then let it go further down the river again. This is very important. The water is stored and then later on it is released further down the river via dams and lakes, and when it overflows the water goes on further, or waterfalls that eat itself away in 1,000 years' time, then the graded profile will occur. But if we come to the permanent base level, there is only one permanent base level, and that is the sea or the ocean. Guys, now if you think of this, a temporary base level is the place where the river stores the water for a certain period of time. Then it is released again. But the permanent base level is the sea. Why? Because the river can't go any further than the sea. Then the river runs into its permanent place and it is almost wiped out, if we can say it like that. The water is mixed with the salty water of the sea. Therefore, the sea or the ocean is the permanent base level. Remember, only two base levels, permanent and temporary. If you have any questions about the longitudinal, the transverse, the permanent or the temporary base levels, please feel free to ask it right now. We now come to the last part of today's presentation, and that is stream piracy and all the features that go along with it. Remember, whenever you hear something about stream piracy, you must be able to identify the following features. What is a captive stream? A captured stream? What is the elbow of capture? What is a misfit stream? And a dry point. Guys, one year when we went marking, one of the candidates were not able to put in words what he tried to tell us about what stream piracy is. So he drew a river with a huge hand trying to rob this water. And that candidate got 2 marks for it, because his picture, his drawing, led the marker to see what he actually meant. The river is being pirated. It is being stolen. Let's make sure. The capture stream. The capture stream is the one that takes the water. In this slide, you will see that the capture stream is indicated. Can everybody see that erosion takes place to the north? It takes place to the top of that graph, of that picture. As soon as that river reaches the other one, can everybody see that it steals the water? Therefore, the capture stream is the one taking it. That is the pirate. That is the one stealing the water. The captured stream is the one from which the water is taken. Right, let's have a look if we can identify that one. Can everybody see that the captured stream is the one that the water was taken from? The captured stream took the water from the captured stream. Now, as soon as the water is pirated, as soon as it is stolen, there are certain features that will occur. First, we get the elbow of capture. Right. Everybody, bend your arm at the elbow. Do you see? It forms a hook. Compare it to that picture. That's why we call it the elbow of capture. That is the point where the water is taken, where that crime of taking the other river's water takes place. Sorry. Right next to that, we get a wind gap. A wind gap is the place, pardon? The wind gap is the place where there is no more so much water. The water has lessened. It has gone down. The water is going to another place. That is called the wind gap. And then further on in the captured stream, you guys will see they call it a misfit stream. A misfit stream is a stream that has less water than the valley it is flowing in. Let's make sure of these features. Does everybody understand what the capture stream is? That is the pirate. The captured stream, that is the victim. That is the one from which the water is going to be taken. The elbow of capture, that is the point where the piracy took place. And then further on you will see there is a misfit stream. Now if I can just go back to the kinds of rivers. Imagine the captured stream. Now that is the one that is being stolen from. Imagine that is a permanent river. Now the river that is the capture stream steals that permanent river's water, leading to a misfit stream, with other words, to less water being in it. Do you guys understand that the top part of that captured stream, the place where the piracy has not taken place yet, will still remain a permanent stream? But the bottom part, after the capture has taken place, that could result in an episodic river or in a periodic river. Whereas, let's say the capture stream is only a periodic river, it can now become a permanent river because it has more water. This is just an example of an aerial photograph, but I just want to show you guys this. It's very, very interesting the Mississippi River, that is the one on the right, is going to be captured in the next, they say, 3 to 10 years by the river on the right-hand side. That's called the Archafalya River, and that's like an Indian name. You don't have to remember that. But on that picture, on that synoptic picture, you can clearly see the elbow of capture. And look at the bottom where it says Old River. Do you guys see that because the river is now being channeled to another place, the Mississippi River, which is a permanent river and a mighty river, has started forming braided streams. Look at the bottom there. Do you see there's an island in the middle of that Mississippi River? Something that has never, ever, ever taken place before. Because the Mississippi River was one of the mightiest rivers in the world until the other river came, and it is taking away its water. If you guys have any questions on what we just did, please feel free. I'm going to recap quickly what we did, and then you guys still have time to ask questions before the end of the session. The first thing that we did was the types of stream flow, which was the permanent stream, the periodic stream. Remember, you must know the features of each of these. The episodic river and the exotic river. Then we did the braided streams. Remember, you guys must be able to identify them on the topographical map. We did the meandering streams. We did the rock-controlled streams that I told you is not as easily identifiable. Then at the flood hydrographs, very, very important. Remember these 4 features: the rising limb, the falling limb, the peak, and the lag time. If you guys are able to identify those 4 features, you will be able to read the flood hydrograph easily, or more easier, and then you will be able to get your answers or derive your answers easier if you can identify those 4 features. The next thing that is important, remember the difference between infiltration and runoff in an urban and rural area, which will lead to different flood hydrographs. There are 2 profiles to a river: a longitudinal profile, that is from its origin to the mouth, always working to be graded or concave, but not being there for long. And then the transverse or the cross profile. The difference between each of those sections, the upper, the middle, and the lower course. The base levels. There are only 1 permanent, the sea, and then all the others are temporary. The stream piracy features. Remember, if you can identify the captive stream and the captured stream, you will also be able to identify the kind of streams that they are. And then please remember the elbow of capture, that is very easy to identify. The misfit stream and the dry point, that is where the water usually flew. If there are no questions, I would like to thank you for your time. Good luck with the exams, and please write legibly so that we can mark easier. Good luck. Hi guys, sorry, this is the aftermath. We have a question on please repeating the features of river capture. Okay, so let's go back quickly. The capture stream, that is the very first feature that you have to know. The capture stream, that is the pirate. That is the one that is going to steal the water. That is the one at the bottom. The captured stream. That is the one who is the victim. That is the one from which the water is going to be taken. That is the one at the top. Look at that picture. It is going, the water is eroding, the river is eroding from the bottom to the top. It's going northwards in this case. It's going to flow, reach the top river, take the water from the top river, and then it is the robber, it is the pirate that is called the captor stream. It takes the water from the captured stream. What is now left? There is a misfit stream. The misfit stream is actually the bottom part of the captured stream. That is where there is more valley than water flowing in it. The other feature is the wind cap or the dry point. They also refer to it as the dry point. That is a dry area. That area used to have water, but now it does not anymore. And that is right next to the elbow of capture. If there are any more questions, guys, please feel free. We still have about 10 minutes. If you want to ask something, please do it now. Guys, there were no more questions, so please enjoy your matric exam. Study hard, read through the questions, answer in such a way that we can understand what you're trying to say, and good luck. May God bless.